I'm ready. There
There
are
are two types.
excellent. The definite integral is a
Is it sum
yes.
of areas? That would a number.
Good. Good. The indefinite integral is a
family of functions.
excellent. Perfect. The area under a graph is approximated using
Is it left side?
the left or the right, but what we're using to approximate the area. We're using, okay, let's go back. What is this?
It's blocks.
Yes, but we are calling them rectangles. Good. So areas of rectangles. Good. The approximation can be n or n.
Over or under.
Indeed, over or under estimation. Estimation. Perfect, awesome. If the function is a velocity function on 0, 4 hours, then the area under the graph of the velocity function on 0 to 4 hours is the exact or is the
Definite integral.
yes, but total distance between 0 and 4 hours. Good, last one. Given a function, which is the derivative of a function, so f prime, f of x represents its very long,
Is it integral?
it's a very long word.
Is it velocity?
Nope, very, very long word.
Antiderivative.
Exactly. Thank you so much. Antiderivative. Good, awesome, excellent, thank you. I think that this is very good to start with every class, so we can review the concepts from before. Awesome. Now I'm ready for any questions you may have, anything that you want to go back to, anything you encountered in my lab math, just anything you want.
Could we do to lab math the section 4.2 and the problem number 2?
Yes. Do I have to, can you dictate it, or do I need to open my lab math?
So the approximate the area under graph A, and our graph A is f of x equals 3 over x squared
Yes.
over the interval 2 to 6.
How many subintervals?
4 decimal places and then adding.
Right, but how many subintervals? Is there a picture
4.
there? Okay,
4.
n equals 4. Okay, perfect. Good. So the graph of this maybe they show it or they not, it doesn't matter. Remember, this is 3 over x squared on the interval 2 to 6. 1, 2, 3, 4, 5, 6, 2 to 6. Looks something like this. This is the graph of 3 over x squared. Of course, it has a vertical asymptote at 0. So this is the graph. So we are asked to approximate this area. Are they telling us using left, using right? What do they want? Leftmost point or rightmost point?
They want left.
Okay, so we want to choose left. Perfect. So here's how we proceed. So first of all, this interval has to be divided into 4 subintervals. So the interval between 2 and 2 and 6 is divided up into 4 subintervals. So this is 6 minus 2 is 4, 4 over 4, so this is 3, and this is 4, and this is 5. The length, or I should say the width of each piece is 1. 1, 1, 1. Since they're asking us to use the leftmost, then I have to use this height, I have to use this height, I have to use, maybe I should put it here, this height and this height. So this will be the first one, this will be the second one, this will be the third one, and this will be the fourth one. Okay? So, therefore, the area with leftmost point and 4 is approximately base times height plus base times height plus base times height plus base times height. Exactly 4. But since the base is always 1, there is nothing, I shouldn't put anything in here. So, f of 2 plus f of 3 plus f of 4 plus f of 5. At this point, the height at this point, the height at this point, and the height at this point. Not at this point. This will be the 5th one. If we're told use the rightmost point, then I will be using this, and this, and this, and this. But I am told to use the left. So left is here, left is here, left is here, left is here. Okay. So then I have 3 over 4 plus 3 over 9 plus 3 over 16 plus 3 over 25. And I get the number. Is this okay? Or do you want me to plug these numbers in, or can you determine
No,
this?
that's okay.
Okay. Is this better? Is it clear now?
Yes.
Perfect.
Yes.
Perfect. Anything else you would like to go back to before we start 4.3? Did you encounter something else that you want to discuss? Anything? Okay, well, in that case, let's continue with 4.3. In 4.3, we are going to learn how to, I know it's called area and definite integrals. Okay, so let's put that, area and definite integrals. Okay, so basically we're determining the exact area. So I'm going to focus on this. So first thing, I want to refresh your memory on one thing. Number one, give me a function, any function you want, because I want to make sure that this is clear again. I know we reviewed this several times. Let's review it one more time. So give me any function you want.
5x squared plus ex.
E to the x. Awesome. So now we have two different things. Please remember the derivative and the differential, which is dy. Can anyone give us f prime and anyone give us dy? They're not the same. The derivative of the function and its differential are not the same. Good. I'm ready when you are. Can anyone give us this prime?
Derivative is 10x plus e to the x.
Perfect. What about dy? Anyone?
10x plus e to the x times dx.
Excellent. Thank you so much. So please understand F prime is just this, but dy is more than just this. It's also multiplied by dx. And you can say, why are you reminding us all the time? In a moment, you'll see. Okay. We just had, last time I should say, we just had some example here that we started with. I came up with a very simple function, which was x squared plus 1 on the interval 0, 2. This was from the last section. Yes, the previous section 4.2, but the last class. And we determined the area so I didn't finish my calculations here. Oh no, I didn't finish my calculations. So f of 0 was 1, f of 1 was 2. So this is 3. You let me move on without, okay, f of 1, it's not your fault. So f of 1 was 2, plus f of 2, 4 plus 1 is 5. So this was 7. So the area with the left was 3, and with the right was 7. So now I'm going to show you a way of determining, what am I doing here? Okay. Now I'm going to show you a way of calculating that between 0 and 2, exact as a breeze. Oh, I took my page away. I guess, no, I didn't. Good. So page 3. Perfect. Okay. So we want to find the area under f of x, x squared plus 1 on 0, 2, exact. So remember, the area with left 2 was 3, and the area with right 2 was 7. Okay? Of course, these are gross approximations, right? Far away from the truth. Okay, but this time we want to find the exact area. Before we attempt that, we have to look at a theorem. The name of the theorem is Fundamental Theorem of Calculus. It has 2 parts, but here we are only looking at one part of it, the one that we need for this. Okay, so what does this say? I'm going to put it in writing first, in words. It teaches us, so the fundamental theorem of calculus, that's what we're talking about. It teaches us how to evaluate a definite integral. That's what it does. It shows us or teaches us how to evaluate a definite integral. Okay, so here is the general example. The integral, we say the definite integral from a to b from a function dx. Okay, very important to understand that. F of x dx is the most general antiderivative. We use a different notation, of course, it's a different function. In other words, this function prime is this function. This function is the antiderivative of this function, evaluated from a to b. But how do I do this? First, I plug in the upper limit. There's nothing to do with the limit operator. Upper number, if you want, f of b minus the lower number, f of a. Now, we have to make a very important remark here. This function must be continuous on AB. Otherwise, we cannot do this. This is not applicable if this function is not continuous. Okay, so then we want to determine, can anyone tell us what definite integral and which function? What do I do? How do I write this? What do you think? It's okay if you're wrong. We have never done this before.
It would be 2 on the top of it.
Yes,
And then
so we say the integral, the definite integral, from 0 to 2 from
the function, which is x squared plus 1 dx.
That's it. This is the exact area under this function between 0 and 2. But now I know how to calculate it. Let's find the antiderivative. Which function prime is x squared?
X cubed divided by 3.
Excellent. Plus, which function prime is 1?
It's
X
just x.
From 0 to 2. Now I have to apply this procedure. What does the procedure say? It says, in this function, plug in 2, and then subtract when you plug in 0. But can anyone tell us what happens for this function? Not for all of them. But for this function, what happens if I plug in 0 for x?
It equals 0.
Exactly. So in this case, this is redundant. Not in general. It's redundant because in our case it's 0. So I'm going to plug in 2, so I get 8/3, plus I plug in 2 and I get 2. 3 times 2 is 8. 8 plus, I'm sorry, 3 times 2 is 6, plus 8 is 14/3. This is the exact. And we got anywhere between 3 and 7, which makes sense. This was an underestimation, this was an overestimation, and the exact area is 14 divided by 3. That's what we study in this section. The Fundamental Theorem of Calculus, Part 1, or just say Fundamental Theorem of Calculus, that's all. That's good enough. And